Hey everyone, and welcome back to another AI video. Today we're gonna be exploring the Wan2.1 Phantom. This model is for those of you who've been experimenting with AI video generation and want more consistent results, specifically for characters and objects. You can use this model to seamlessly place objects and different characters together in a video. The Phantom Wan 2.1 is an upgraded and fine-tuned version of the Wan series designed to bring real subject consistency to image to video generation. I've spent the past week testing Phantom Wan 2.1 using different prompts, hardware setups and workflows, and I can say this model feels like the first real step towards stable, story-driven AI video content. Over the next few minutes, I'll share my personal experience, insights onto its features, benchmarks and some unique prompts to help you get started confidently. Let's dive into the video. Phantom Wan 2.1 is a diffusion-based AI video model. It builds upon the original Wan 2.1 series, but with added support for what's called subject consistency. That means the AI remembers the character, outfit or object and tries to keep it visually consistent across all frames in a video. The model comes in two main variants: the Phantom Wan 1.3 billion parameter lightweight version and the 14 billion parameter full model. The 1.3 billion model can run on just 8.19 gigs of VRAM. That means you can run this on a standard RTX 4070, RTX 3080 or even some higher end RTX 3070 GPUs. The architecture uses something called VACE. It's developed using Phantom subject to video method, so it doesn't just generate random moving shapes. It actually tracks the character's facial structure, clothing style and pose consistency. This is especially useful for those of us trying to build character driven stories, product ads or visual try on demos. Now let's talk about performance, because this is where Wan 2.1 really shines. As you can see over here, the Wan 2.1 scored 86.22% and you can see it has ranked higher than some of the private models like Sora and even higher than some of the good open source video generation models like Honeywan Video. If you're using a normal gaming PC with an RTX 3060 or similar GPU, here's what you can expect. You can expect 81 frames or about 5 seconds of video, resolution of up to 480p, and it uses around 8 gigs of RAM to give you really good results. VBench evaluates models across 5 key dimensions, which are human fidelity, controllability, creativity, physics and common sense. And as you can see, Wan 2.1 performs significantly better in these areas compared to other open source models and even some private models. Here you have a visual depiction of performance of Wan against some of the other video generation AI models. This purple line is for Wan, and as you can see in these areas which relate to color, human action, scene, multiple objects, the Wan 2.1 performs significantly better than the other models. For the physics simulation part, we're going to be testing our model by providing it with some prompts relating to elements like fire and also testing some closed simulation as well. Now let's start with installing the models and setting up our workflow. First up, the system requirements. For the 1.3B model, you need to have at least 8 gigs of VRAM, 16 GB system RAM and about 15 GB of free storage space. Python 3.8 or newer is required along with CUDA 11.8 or 12.1. If you don't have access to this compute, you can always use online compute platforms like runpod. I have a whole video on how you can set it up and it's up on my YouTube channel. Okay, moving on to installing the models and setting up the workflow. You can simply do that by opening ComfyUI and dragging and dropping this workflow. I'll have a link to this in the description down below. Once you have the workflow loaded up, you need to install a couple of models. Some nodes might show up as missing. What you can do then is simply go here and install missing custom nodes, and a bunch of nodes will show up as missing over here. You can simply click on all and install them, but I don't have any missing nodes right now. What you need to do afterwards is to install these particular models. If you bring your cursor on any of this, you can see where in the directory that model is placed. So you can simply download these models and place them in the relevant directory. I will have a link to all of these models in the description and also in the note over here. I'm gonna add all the links to the models you need for this. Basically, you're gonna need this one, then you're gonna need the 1.3 or the 14 billion parameter model for the Wan, and you're gonna, for encoding and decoding, you're gonna need the Wan VA encoder and decoder, so it's gonna be this one. Again, I'll have the links to all of these here in this note. First up, for testing, we're gonna only be using 2 images. After that, we're also gonna try it with multiple images, because this workflow allows you to add up to 4 images at a time to generate a video. One more thing you have to be really careful about is if you generate more than, I would say, 80 to 90 frames at a time, there's a lot of artifacting going out in the output video. So I'm going to show you an example. So the number of frames is 121. Let's load up our images over here. So we have a subject over here and a background over here, and for the prompt I'm simply gonna write. Of course, the more descriptive you are here in the prompt, the better the output is going to be, but we're going to click on run and let's wait to see what results we get with this. The first time around, it's going to take a while to load this onto GPU, but after that, the subsequent video generations are going to be much faster. And this is the result we've gotten, and as you can see, there's a lot of artifacting going on in the background, which is what we expected by generating a really long video. Suffice to say, we cannot use this video for anything. So now let's try and lower the number of frames. I'm gonna generate 60 this time, and let's click on run again and see what results we get with the same seed number. And this is the result we've gotten by reducing the length of the entire video. And as you can see, in terms of the background, there is less artifacting going on compared to the earlier video. In order to get really good results from this model, the inputs you provide needs to be loosely aligned with each other. For example, in this case, the girl was walking sideways, but in the background, you can expect the girl to be facing towards the camera, but the image I've provided contradicts that. We're gonna try something else now. Next up, I have uploaded an input image of Tom Cruise and a PS4 controller, and like I mentioned earlier, the direction of the objects or where the objects are facing needs to be loosely aligned. So in this case, the PS4 controller will be in this position if he's holding it in his hand over here. And as you can see, it's much better than our earlier generation, where the background and the direction the character was walking in was contradicting each other. Now there's some artifacting going on with his face over here, and of course you can write a really detailed prompt in order to try to fix that. Now we're gonna try and generate some elements. Let's write a different prompt over here and let's see how good this model does with different elements like fire. This time around, we have gotten a really interesting output because he for sure is walking through a burning forest, but he's holding a PS4 controller, and I forgot to remove that part here in the prompt, so let's remove that. But if you want Tom Cruise to play a game while walking through a burning forest, you can definitely do that using this model. He seems to be really happy with the situation he's in right now, so why not? We are also gonna try and reduce the entire length of the video further to see how it affects the quality, because what happens with these models is they are trained on specific length of video, and if you tend to move far away from that particular length, the quality of the output result degrades. And this is the result we have gotten this time. As you can see, he's dropped the PS4 controller and the forest fire has somewhat turned into a campfire, but we can fix that by writing a detailed prompt. Let's try and add way more detail to the prompt this time, and I'm also gonna add 4 images instead of 2 this time. Okay, so I have added 4 images. I have written a description of the scene: a woman in a red trench coat holding a vintage umbrella walking on a rainy cobblestone street. Let's make sure all the models are correct over here. I'm gonna select this one over here, and for the VA I'm gonna select this one, and also I'm gonna reduce the video length once again to around 60, and let's click on generate and see if this model can put together these 4 images into a coherent video. This is the result we've gotten by providing those images as input to the Wan Phantom, and I gotta say the results are pretty amazing. Now I'm sure any video like this was not part of the original training dataset for this model, and it's pretty amazing how the model is able to seamlessly put together different objects and characters in a single video. Now we're gonna try one more example. I'm gonna now change these images. Now I have written this prompt this time around. A man in a grey suit sits at a small cafe table with a violin resting on the table, while a cat sits on the chair opposite to him under golden sunset lighting. And for the images I've provided, once again you can see these images need to somewhat align with each other. So for example, if the violin is resting on the table, its position needs to be exactly this. The man will be sitting on this chair, and I'm assuming the AI will put the cat on this chair. Let's click on run and let's see what the AI generates for us this time. And this is the result we've gotten. This is not exactly what we were looking for. For some reason it has put cat and our main character on the same table, and there's another dude sitting in front of them and holding the violin. Let's try and change the length of this video and also the seed, and let's try and see if it has an effect. We've changed the length from 61 down to 41, and I've also changed the seed around this time. Let's see if AI can pull this off this time around. And this time around, as you can see, the AI has managed to put together the scene pretty well, but there is no motion, and we didn't describe any motion here in the prompt. Now let's talk about a few places where this thing falls short. First up, like I explained earlier in the video, if the images you are providing to the model, if they don't align really well, the AI won't be able to make a coherent scene. The second one is if you try to generate a really long video, the model tends to add a lot of artifacting to the output result. How you can fix that is you can generate a shorter video, and then you can provide that to Wan2.1 image to video, and you can add a prompt as well to provide context, and you can continue generating the video. Also, if there is extremely rapid motion, it still causes some artifacting. Very specific brand recognition or text rendering isn't reliable in this model yet. If you need readable text or specific logos in your generated content, you likely need some post-processing for that. The fact that you can run high quality AI video generation on RTX 4070 is truly revolutionary. The Wan2.1 really shines compared to its competitors. The model can maintain distinct character identities and interactions across complex scenes without the characters morphing into each other or losing consistency. So if you want to generate videos of elaborate dinner party scenes or classroom interactions, you can use this model. Also, if you want to generate elements like water, fire or smoke, or if your character is walking and there are clothes simulations, this model tends to handle them decently well. Obviously it's not perfect, and I don't think open source models are there yet, but it's getting pretty good. What's also amazing is how this model can take totally different unrelated objects and backgrounds and put them together coherently in a single scene, especially if you're pretty descriptive with the scene and you also define each object present in the video and the environment and the lighting. The model puts them together really well. Also, the model's ability to generate content across radically different artistic styles while maintaining coherence has created a new category of viral art content. So that's it for this video, guys. If you have any questions regarding the workflow or regarding the model, you can ask me down in the comment section below. I will have links to all the models in the description and also the workflow. Be sure to let me know your thoughts about the model down in the comment section below, and I'll be seeing you in the next one. Cheers.